Welcome to Lecture 4. This is for College Algebra, Mac 1105. My name is Jorge and in this lecture we're going to be talking about equations and inequalities involving absolute value. So we have two objectives. The first one is that we're going to solve equations that involve absolute value, and we're also going to solve inequalities that involve absolute value. So let's talk about absolute value real quick. So let's say that A is a positive real number. And let's say that u is any algebraic expression. Then the absolute value of u equals a is equivalent to saying that a is either a positive a, or u is either a positive a, or u is a negative a. So there's two possibilities when we take out u from the absolute value restrictions. So let's look at two examples. So here, on the left hand side, I have the absolute value of x minus 3 equals 10, and then on the right hand side I have the absolute value of 2x plus 1 minus 3 equals 7. So we're going to go ahead and solve each one of those. So the first thing that I do is for a is again, it can either equal positive 10 or negative 10, so I have to solve it for both possibilities. So x minus 3 equals 10, or x minus 3 equals negative 10. So at this point in time, I'm just going to solve them the way that I normally do. So I'm going to add 3 to both sides. So on the left hand side becomes that x can be 13, or x can be negative 7. And if we check both of those values into the absolute value, so 13 minus 3 is 10, the absolute value of 10 is 10. Now, negative 7 minus 3 is negative 10. The absolute value of negative 10 is 10. So both of those values work. So the solution set here is negative 7, 13. So let's look at B. So here I have the absolute value of 2x plus 1 minus 3 equals 7. So the first thing I want to do is I want to add 3 to both sides, and that's how I got the 10. And just like on the left hand side, when I remove the absolute value restrictions, I'm either going to have a positive 10 or negative 10. So I have to solve for both possibilities. So the first one, what I'm going to do is subtract 1 from both sides, and I'm going to do the same thing on the second one. So then I end up with 2x equals 9, or 2x equals negative 11. So now what I'm going to do is I'm going to divide by 2. So I get x is equal to 9 halves, or x is equal to negative 11 halves. So my solution set then becomes negative 11 halves and 9 halves. So the next thing we're going to talk about is inequality. So here I have the absolute value of x is less than or equal to 3. So we're going to go ahead and solve this one. And what happens is that there's, again, two possibilities. So when I remove the absolute value sign, so either negative 3 is less than or equal to x, or x is less than or equal to 3. Or my solution set would be negative 3, 3, and here it is when we graph that inequality. So here's the theorem. If a is a positive number and if u is an algebraic expression, then again the absolute value of u is less than a is equivalent to saying negative a is less than u less than a. If the absolute value of u is less than or equal to a, that's equivalent to saying negative a is less than or equal to u less than or equal to a. So in other words, the absolute value of an algebraic expression, in this case is u is less than a, is equal to either negative a is less than u, or u is less than a. So let's go ahead and solve this inequality. So here we have the absolute value of 3x minus 1 is less than or equal to 5, and then we're going to go ahead and graph the solution set. So again, I have to write it out. So I have my two possibilities. So negative 5 is less than or equal to 3x minus 1 less than or equal to 5. So what I'm going to do is I'm going to go ahead and solve this all three parts at the same time. So I'm going to add 1 to the left, the middle, and the right. And what that's going to do for me is it's going to get rid of the negative 1 in the middle part of 3x minus 1. So now I have negative 4 is less than or equal to 3x less than or equal to 6. So now I divide everything by 3, and then I simplify. So then I end up with negative 4/3 is less than or equal to x less than or equal to 2. So then my solution set then becomes all x such that negative 4/3 is less than or equal to x less than or equal to 2, or just use the brackets to write my solution set. And so the way that we graph it is just like that. So if you notice, my endpoints of my line are the same as my brackets, and we use brackets because it's less than or equal to. So here we have another inequality. So here we have the absolute value of 3 minus 2x is less than 4. So we're going to solve this and we're going to graph the solution set. So again, here are my two possibilities. So what I'm going to do is I am going to subtract 3 from the left, the middle, and the right. And so I'm left with negative 7 is less than negative 2x less than 1. And I divide everything by negative 2. And if you remember, when we divide by negative value, our symbols are going to change direction. I simplify. So here's my solution. So 7/2 is greater than x, greater than negative 1/2. So here are the two ways that I can write that out. And I use parentheses because it's a greater than. And then we go ahead and graph it. Okay, so the next example, we're going to go ahead and solve the absolute value of x is greater than 2. So here we have, oops, sorry. So let me just go ahead and get all this on the screen so I can move on. So absolute value of x greater than 2. So either x is less than negative 2 or x is greater than 2, right? We did that previously. So my solution set then becomes negative infinity to negative 2 union of 2 of infinity. So what happens is that any value between negative 2 and 2 is not part of the solution set. So these values in between here don't solve this inequality. Values that are less than negative 2 and values that are greater than 2 are the only ones that solve this inequality. And if you think about it, well, absolute value of negative 3 is 3, 3 is greater than 2. Absolute value of 3 is 3, 3 is greater than 2. So, but if I pick a negative 1, let's say, so absolute value of negative 1 is 1, 1 is not greater than 2, so therefore these values here are not part of the solution. Negative 2 is not part of the solution because the absolute value of negative 2 is 2, and 2 is equal to 2, 2 is not greater than 2. So here's the theorem. If a is a positive number and u is an algebraic expression, then the absolute value of u is greater than a is equivalent to u is less than negative a or u is greater than a. Absolute value of u is greater than or equal to a is the same thing as saying u is less than or equal to negative a, or u is greater than a. So let's solve this inequality. So here's the absolute value of 3x minus 2 is greater than 7. We're going to solve it and graph the solution set. So here I have two possibilities, right? So 3x minus 2 is less than negative 7, or 3x minus 2 is greater than 7. So what we're going to do now is going to solve them both at the same time. So I'm going to add 2 to both sides. So I end up with 3x less than negative 5, or 3x greater than 9. I divide by 3. So here my two possibilities. So x is less than negative 5/3 or x is greater than 3. So here's my solution set. Here's in set notation. So it's all of the values that are between less than negative 5/2 or values greater than 3 to infinity. And the way that we graph it is like this. So again, 3 is not part of the solution. Negative 5/2 is not part of the solution. So any value in between here does not solve our original inequality. Any value from negative 5/2 to negative infinity will solve it, and any value from 3 to infinity will solve it. And that's the end of lecture 4, absolute values, equations, and inequalities. Thank you.